Hello, everyone. So let's get started here um, in a few minutes. Um, I'm going to be talking about a medication here um, and the disease states associated with this medication. Um, so before I start, my name is Snehal Desai, and if anyone has any questions or anything about the contents that I have previously posted on our Farbits YouTube channel, please feel free to let me know. Um, so this is a very interesting medication. I I don't know how to really fully pronounce it, but it's a it's not a common medication that's used, and I think the mechanism was really interesting. So I'm going to talk a little bit about it. The information might be a little bit more complex online, so I've broken it down here for your knowledge. Um, this is primarily a um, the medication name is Tividenofusp, uh, and give me 1 second. I think we're having little issues here. I think we're having little issues here, so give me a minute before we start. Um, okay. So everyone present here. Okay. So this is a medication, Tividenofusp, and it's a very interesting medication. It is given IV, it's once weekly injection, but I want to talk a little bit about the disease state itself that it's used to treat. So in this case, before we start, there's just going over specifically on cell biology basics here, you can see that in this diagram here, there are different parts of a cell. It doesn't matter which cell it is. It could be a liver cell, a nervous cell, it could be a brain cell, it could be a kidney cell, a liver, spleen, any of those. So basically what happens here, you have the food particles you have that come into it, and then they get broken down to different pathways. The Golgi apparatus, which is essentially like your kind of like a post office, kind of like, making sure that the address is on there and takes you to a destination. So that's the delivery, packaging delivery center. Then you got the endoplasmic reticulum, which is composed of the small and the rough endoplasmic reticulum parts that have different roles that they play. Then you have the cytoplasm, which is essentially kind of like those little juicy areas within the cells where all of these organelles are. The lysosome. Um, then there is the digestive vacuole, things that bring in the waste and stuff like that. You got lysosome, which is the most prominent, the very most important part of this discussion today on this medication, tividenofusp. And so I'm going to talk a little bit about it because this can be a little bit confusing to some of you all. And so we're going to see, just give me a minute. I think there has to be a little bit of um, information loss here. So, anyways, so this is like a cell, and then these are the different parts of organelle. There's also um, uh, a neuron here, obviously, where the endoplasmic reticulum is, and then you got this part here. I didn't include it here earlier, but I'll include it right here for you all now. Um, like there is a DNA here. inside the nucleus. This is the nucleus. Okay, so we got all the pieces together here. The lysosome is essentially where all the trash is taken. It's kind of like breaking down old proteins or old enzymes and everything, and then reusing, recycling kind of thing. So, this is an interesting medication, and I'm going to go over it now for your review. So a little bit more on the breakdown of the organelles. So the endoplasmic reticulum, you can see it's made up of rough ER and the smooth ER. And you could see the smooth ER is actually used for like lipid and cholesterol synthesis, steroid hormone production, detoxification of drugs, toxins, calcium storage, all of those things. But in the rough ER, which obviously rough, meaning starting with the R, ribosomes, you can see the ribosomes are actually attached to the endoplasmic reticulum itself. And there are also some floating around freely in the cytoplasm parts of the cell as well. What is the purpose of the rough endoplasmic reticulum? Well, obviously it's acting like a factory. It's where the proteins are usually built out. Ribosomes are used to actually transcribe, translate, make those proteins from its amino acids and all. Those proteins are used for like, cell membrane itself, either secreted to other hormones and other parts of body. It's used to, also probably sent to a lysosome. Maybe there's some proteins because the ribosomes make it for certain enzymes that the lysosome needs to break down the old stuff inside that's within the cell. So um, just to keep that in mind, the endoplasmic reticulum, you could see it typically first goes through Golgi apparatus because the Golgi apparatus is where it gives you the destination, where it should go once the protein is made, and how it should be delivered. So the delivery process is obviously going to be through the Golgi apparatus, and it's going to go to, other parts of the cells and, um, you know, and see where it's ending up or how it's getting transported and all of that. So right here at the Golgi, it basically tags protein addresses. It tells it kind of gives an address saying, hey, I'm going to send you to this lysosome. I'm going to send you a membrane, or I'm going to have you go to a hormone outside a cell, or some other place. So that's essentially what the Golgi apparatus does. Um, Lysosomes are essentially used to break down many of the old proteins, lipids, carbohydrates, damaged organelles, pathogens, and then later on these things can be reused. Now the lysosomes themselves are just like a storage vesicle, basically. But what actually breaks it down are the enzymes used to break down. There are certain enzymes used to break down these types of things. So these enzymes are actually, the enzymes are essentially proteins, and proteins that are made by the ribosomes. Okay, so now the next thing is here is the Hunter syndrome. Hunter syndrome is a mucopolysaccharidosis type 2, which is a lysosomal storage disease caused by failure to break down certain complex sugars. Now, how does this actually happen? Well, first of all, there's an enzyme I talked about earlier. That enzyme is used by the lysosome to break down certain things, including some storage sugars, like I said, carbohydrates, and there's some sugars and stuff. But when the gene within the nucleus of that cell of the DNA is mutated, it prevents the ribosomes from building a proper enzyme to break down that um, complex sugar. And so typically, this complex sugar are defined as glycosaminoglycans, GAGs, and it's basically going to build up within the lysosome. So they are typically used for structural connective tissue, lubrication of joints, cartilage, cell signaling, maintaining tissue hydration. But sometimes some patients, those typically in children's the age 2 to 4 years, they're going to have some rare X-linked lysosomal storage disorder, and that may lead to a deficiency that it's caused by deficiency that leads to an enzyme defect of accumulation of glycosaminoglycans. And so that accumulation is going to um, build up and eventually make the cell swell basically, and kind of like damage it. And that's in all different types of parts of body, including the brain. So it's very important to, certain structures, hormones and bone skeletals might be kind of malfunction due to this kind of damage by rare X-linked lysosomal storage disorder. And so it's an interesting thing to see that something like this might get disrupted inside the body and lead to those kinds of damage. So what is actually happening here is that the DNA is essentially mutated because of the IDS gene is mutated there. Then it gets sent out, signaling, obviously, the ribosomes, they're not going to make the proper gene, or not the proper, they're not going to make the proper enzyme that's used to break down um, these GAGs, as I mentioned earlier. So, in the lysosomal storage disorders, the toxic materials can build up inside the lysosomes. And so, this is going to lead to like coarse facial features like macrocephaly, enlarged tongue, stiff joints, short stature, and hepatosplenomegaly, and those kinds of things would start to occur from the very young age as you get older. Um, so what can we do to resolve this issue so that this patient doesn't continue to experience those kind of damages inside the body due to this rare genetic defect from a very small part of it that's mutated within the DNA. Well, there's one way to think about it. So obviously, you can use a medication to just replace the iduronate 2-sulfatase enzyme, which is typically used to break down the GAGs. Um, but there have been some drugs that have been used to work in the somatic parts of the body, like the somatic organs, such as like the liver, the spleen, the kidneys, all the other parts except for the brain. So what about the brain? So this is the one that because of this medication is going to be very useful because it's administered as a once weekly intravenous infusion. It binds to the transferrin receptor on the BBB. It is a Denali proprietary um, transport vehicle drug delivery technology. So it's designed to work and target the receptors on the blood-brain barrier, which are the transferrin receptor, and it's going to the cell within the um, endothelial cells, which actually separates the brain from the blood. It's going to pull it inside the brain. Now, the drug, once it pulls it in, obviously it's going to go gets into the neuron cell, and then obviously once it goes in, it's going to essentially um, give the right ideas it needs to um, not the ideas, sorry, the I2S, which is essentially the enzyme I2S by the Tividenofusp, okay? And it's going to essentially replenish that so it can start, making things normal again, causing a reduction in the buildup of, reducing that buildup of the GAGs. And, it's going to be used by the lysosome, so it'll work on somatic organs as well as the blood-brain barrier. So this is a very good advantage in treating those kinds of patients with this kind of rare genetic defect of Hunter syndrome. So I just wanted to talk a little bit about this medication. I hope this has been a little bit interesting and useful to you all in your practice. Um, it is a, very rare. Uh, I haven't really seen it used much in practice or anything, but it's interesting to at least have an idea how this drug is used and what it's used for and all of that. So, um, if any of you have any questions, please feel free to let me know. Again, you can always visit our live streams and our videos on all of these topics and much more on our FarmBits YouTube channel. Um, so, um, and if anyone has any questions for me specifically, you guys have my username, so you guys can message me at any time. I hope this has been an interesting video and hope you all have a good day. Thank you for watching.